Okay, so we just talked about vertical and horizontal translation. So can I get a brave soul to tell me what they think this big, oh look, it just messed it up. Did you guys see it? Yes? No? Alright, so what would be this equation? Absolute value of x plus 1. So then what would this one be? Absolute value of x minus 2. Correct? That's what we did last week. Okay. That was kind of just like preview, review. Alright. Pencils down. Let's take a look at this. A recycling company pays $5 for every full box of newspaper. They do not give any money for partial boxes. Draw a graph that shows the amount of money for the number of boxes brought to the center. Alright, so I'm going to label our axes. So this is going to be $5 for every full box of paper. So I'm going to make this the 5, this is going to be 0, 5, 10, let's see, 15, 20, 25, 30, 35. And over here I'm going to put the boxes. Alright, so it says $5 for every full box. So for one box, it's $5. For 2 boxes, how much is it? 10. And then for 3 boxes? 15. Okay. But here's what happens. What if they bring in 1.5 boxes? It's still only 5, right? So all the way until you get to 2 full boxes, it's still only $5. You guys see that? So all the way until you have 3 boxes, it's still $10. And all the way until you have 4 boxes, it's still $15. So do you guys see how I'm drawing that line? What does this mean, this open circle? Not only if I had a graph like this, and it was at 5, and I had an open circle, what does that mean? What if I had this? What does this mean? What's the difference between these two? One in says I have 5 or more. 5 or more. And this one means more than 5. Does it say I have 5? Does this one say I have 5? No, it says I have more than 5, right? So if I have an open circle, it means it's not included in the graph. So if I have an open circle right here, it means that as soon as I get to 2 boxes, that's not included in the $5 price. So I'm going along, I have 2.5 boxes, I have 2 3/4, I have almost 3. As soon as I hit 3 boxes, it's no longer involved in the $10. It steps up to the 15. That's what's happening here. Okay? These aren't done very well. Go ahead and copy this down. Okay, let's look at this a little bit closer. so this is what's happening here. I plug in x, and I get the function of x, or y. Correct? I'm no longer going to put y there. It's going to be f of x. Okay, so I bring in half a box. How much am I going to get? Nothing. If I bring in 3/4 of a box, how much am I going to get? Nothing. If I bring in 0.99 of a box, what am I going to get? Nothing. As soon as I bring in one full box, I'm going to get $5. I bring in 1.5 boxes, how much am I going to get? 5. This is called a step function or a greatest integer function. So rather than give you some fancy definitions, let's just work with it. All right, so the greatest integer function written, f of x equals with the way it's written. It looks like absolute value, but it's got like, you'll either see it like this with 2 lines, or you'll just see it like this. That's a greatest integer function, or a step function. All right, so this symbol means the greatest integer less than or equal to x. All right. So that's a very complicated definition. I think it's much easier if we just start using it, and then you'll get an idea for it. All right, so based on our behavior of graphs, what do you think is going to happen with this one, x plus 1? How is that going to translate? Is it going to translate vertically or horizontally? Okay. How would this one translate? If it was an absolute value function, would that one go, would that go vertically or horizontally? No, not vertically. Remember, when it's inside the absolute value, this is a horizontal translation. And when it's outside, that's a vertical translation. Correct? That's what we were just talking about. Okay. So, what do you think is going to happen with this step function? Is it going to translate vertically or horizontally? Horizontally. Is it going to go to the right or to the left? It's going to go to the left, right? Because there should be a negative in there, correct? All right. See where I'm going with this? So we all understand the behavior of it? All right, let's put some values in and see what happens. So if I put in, this is x, this is f of x. If I put in 1, I'm going to get 1 plus 1 equals, let me move this over, which is 0. So if I put in 1, I'm going to get 0. Sorry. Why are you guys not stopping me? If I put in 1, I'm going to get 2. Okay, what if I put in negative 1? I'm going to get 0. If I put in negative 1, I'm going to get 0. What if I put in 0? What am I going to get? I'm going to get 1. What's happening in between here? I'm going to show you right now. Let's put in something bigger than 1. Let's put in 1.5. What do I get if I put in 1.5? What is 1.5 plus 1? 2.5. All right, now this is where it starts to get complicated, in case you didn't think it was complicated already. So if I put in 1.5, 1.5 is right about here, right? I get 2.5 up to not quite up to 3. The greatest integer function means that the greatest integer less than or equal to x. What is x? What did I put in? Okay, so what's the greatest, okay, let's discuss this. Is 1.5 an integer? What are the integers? Remember we talked about all different types of real numbers? We have whole numbers, we have natural numbers, we have integers. What numbers are the integers? Numbers on the number line. Is 1.5 on the number line? So is it an integer? It's not. What's the closest integer to 1.5? The greatest integer less than or equal to x. You think so, right? In math, you always taught to round up. If it's 1.5, you round up to 2. With greatest integer functions, it's the opposite. You're not allowed to round up. It's like if you're on a step and you're not quite there. See how I'm not quite up to the next step? Did I make it up to the third step? No, so it falls back down right here. It's kind of like this, guys. Did I make it up? If I put in 1.5 boxes, did I make it up to the 2 boxes? No, so I get paid for the one that's right below it, right? It's the same exact concept. That's why I used that real-life example first. So when I put in 1.5, do I get up to 3? No, I don't. So my answer to this is 2. I didn't get up to the next integer, so I fall back down to 2. Let's do another one. Let's put in 0.5. If I put in 0.5, what do I get? I get 1.5. What's the closest integer to 1.5? 1. So if I put in 0.5, I go up to 1, 1.5. Oh, didn't quite make it, so I fall back down to 1. Does that help a little bit? Let's do another one and see what happens. Do you guys have this one in your notes? No. Okay. Do you have this one in your notes? Good. Good. How is this one going to translate? Is it going to translate vertically or horizontally? It's going to translate horizontally. In the positive direction or the negative direction? In the positive direction. So I'm guessing it's going to start over here at 3. Correct? And it's going to step. I'm just guessing it's going to do this. Not yet. And then it's also going to go in this direction, right? Let's see what happens. Okay, tell me what to put in. Let's guess some points. What? 1? So if I put in 1, I'm going to get 1 minus 3, which is negative 2. If I put in 1, do I get negative 2? That works, right? See how step function? A step function is always going to looks linear, right? Going in a line. Let's put in 2.5. What do I get if I put in 2.5? What do you guys think? What's 1 minus 2.5? Negative 1.5? You want to try something easier? Let's try 3.5. What do I get if I put in 3.5? What's 3.5 minus 3? 0.5, which is 0. So if I put in 3.5, I'm still going to get 0. Did that work? Okay, now you want to try something like 2.5 and see what happens? Okay, if I put in 2.5 and I subtract 3, what do I get? Negative 0.5. Okay, let's look at our step function. I go over to 2.5 and I get negative 0.5. What happens? You didn't make it up to the 0 point, so what happens? It falls down, right? It falls down to what? Negative 1. See how when you get in the negatives, it gets a little bit more complicated? Okay. So you guys don't have this one, correct?
Yeah.
Let's get to one where you guys can mess with that. Fraction. It's not that big of a deal. Okay. X and f of x. All right, can you guys predict what this is going to do? You think it's going to be horizontal? Okay. Anybody else? All right, let's check it out. What should we put in? What should we plug in? What would be the easiest thing to plug in? You want to plug in 3. Awesome. So if I plug in 3, I would get 3 divided by 3, which is, what's the greatest integer after 1? We're from 1. What comes from that? What would come out of this? 1. Okay, is 1 an integer? Yes, so that one works. So if I put in 3, 1, 2, 3, I get 1. Pick something else. Let's substitute something else and see what happens. You want to put in 6. I think there's something easier. 0. Wouldn't 0 be easier? What's 0 divided by 3? Is 0 an integer? So it's just 0. So if I put in 0, I get 0. What happens? Okay. What if I put in 2? What happens if I put in 2? Is 2/3 an integer? So what's it going to fall down to? 0. So if I put in 2, I get 0, right? So isn't this going along like this until I get here? So what happened to my step function? Let's put in negative 3. What happens? What happens if I put in negative 3? What do I get? Negative 1. So negative 3, negative 1. So how does my step function, what's going on with my step function? So if this one shifted to the right and this one shifted over to the left, what happened with this one? Did it shift? started at 0, 0. Did it shift? I don't really think it shifted, guys. It did this. Like if you were to take a picture of one of these, didn't it just stretch? Isn't that all that happened? How much did it stretch by? A factor of what? It's right there in front of you. It stretched by a factor of 3, right? It stretched out by 3. Okay, make sure you have this written down. 3, 2, 1. Let's look at the next one. Okay. So what would be the inverse of making really long steps? Short steps. Do you think that this is going to shift horizontally or vertically, though? Okay, this is going to be shorter steps because you're going at a faster rate, kind of like going at a faster rate up the stairs. This is going at a slower rate, so you're walking along really slow before you get to the next step. This is the way I like to look at it. This one's going to be shorter steps because you're going at a faster rate. So what would you like to substitute in here? What would be the easiest thing to substitute in first? 0. If I put in 0, what am I going to get? 0. There's beginning, right? That's the vertex of this function, correct? Like we said, it wasn't going to shift vertically or horizontally, right? We just know that the steps are going to be shorter based on our prediction. Okay, so what do you want to put in next? I put in 1, right? Let's put in 1, what do you get? So if I put in 1, I get 2. What do you think is going to happen if I put in 2? I'm going to get 4. 2, 3, 4. So my step function looks like this. Is that right? No. It's almost right. We have to consider something. We have to consider what's happening if I go half of a step. What happens if I go half of a step? What do you think? What's 1.5 times 2? Is 3 an integer? So if I go over 1.5, where am I going to be? 1, 2. Aren't I going to be right here? So what's happening? So if I put in 1.5, I can't, my step isn't that long. Check this out. My step's only that long because it stepped up right there, right? So this must go over to right here. What if I put in 0.5? What do I get? What's 0.5 times 2? Yeah, 0.5 times 2 is 1. So if I put in 0.5, I get 1. You see how these are shorter steps? So I pulled up GeoGebra right here. I put in this one right here. F of x equals the greatest common integer to x. That's what's in black right now. Here, it's with the 2 on the outside. We'll turn that one on. Why? Why is it not turning on? There it goes. See how I turned it on? How the steps are now. You see it? Okay, so how I could put this in is down on the input down here. You guys see how I just, on this bar down here? So I put y equals, let's put in another step function. Let's put in 2 for, it's also called a floor function. Or, how do you want it to shift? Over to the right? Okay, so I would put x, if I want it to go to the right, do I want to put x minus something or x plus something? Minus. X minus what? How much do you want it to shift over? 2? You see it over here now? It's shifted over 2. It's still stepping really, really big with that gap in it because the 2 is on the outside. See that? We can make it green. That way you guys could see it better. See that? How you can put that in? So write that down on your paper as well. 4. You can call it a step function, or you can call it a floor function. Okay. All right, one more thing I want to show you. All right, let's talk about domain and range. So if I'm talking about, what do we call this? The domain highlight. If I'm going along here, am I going to run into a graph? If I go to the left, am I going to run into a graph? I am, right? Because I haven't graphed it, but this, technically, all of these are going down here, stepping all the way down here, correct? So what will be my domain? All real numbers. What will be my range? As I go in this direction, would also be all real numbers, right? It would be all real numbers because technically if you put in 0.5, it still has a value, right? It's just, it's not being represented on the graph. It's dropping down to the next one.